In this video, I'm going to go over a couple problems from the Unit 1, Part 2 Quadratics practice. So in this practice, you are to solve these equations and you need to choose between quadratic formula, completing the square, and factoring. So when I'm trying to solve a problem, the first thing I'm always going to check if it's factorable. So for example, number 2 is something that I would solve by factoring. And I can see that I can solve by factoring because I can see I have a GCF of 5. And then after I take out that GCF of 5, I can see that I have x squared minus 25, which is a difference of squares. So that'll factor into x plus 5, x minus 5. Now to solve, I'm going to set each of my factors equal to 0. This 5 in front does not affect my solution, so I don't need to worry about that. And so I get x equals negative 5 and x equals 5. Another option is completing the square. When I complete the square, I will typically only solve this when my a is 1 and my b is an even number, such as in number 1. I'm going to complete the square. So when we complete the square, I move the c value to the other side, so that way I can make the left side a perfect square trinomial. Now to figure out what goes in that blank, I'm going to use this little formula of half b divided by 2 squared. So in this case, that's negative 12 divided by 2 squared, which would be negative 6 squared, or 36. Now I'm going to factor this left side. So I need to think about what multiplies to 36 and adds to negative 12, which would be negative 6 and negative 6. But I can write that as x minus 6 squared. And then I'm going to simplify this right side by adding negative 10 plus 36 is 26. Now to finish solving this, I'm going to take the square root of both sides, and I'm going to get x minus 6 equals plus or minus the square root of 26. Then to finish solving for x, I'm going to add the 6, so I'll get 6 plus or minus the square root of 26. Or you could write it as plus or minus the square root of 26 plus 6. Either way is fine. So now, if something is not factorable, or we can't solve it by completing the square because the a is not 1 or the b is not even, then our final option is to do quadratic formula. So in number 4, this is an example of something that's not factorable, and also we will not solve by completing the square. So I'm going to do quad formula for this one. And so our quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, my a is 4, my b is 10, and my c is negative 22. So I'm going to do negative 10 plus or minus the square root of 10 squared minus 4 times negative 22 all over 2 times 4. So I'm going to have negative 10 plus or minus the square root of 452 all over 8. So we could leave our answer like this, but 452 will technically break down into 4 and 113 and 2 and 2. So I can simplify this by writing it as 2 square root 113 over 8, which will then simplify to negative 5 plus or minus the square root of 113 all over 4. So whether you leave your answer like this, but technically the most simplified answer will look like this. I'm going to do one more example of factoring that's a little bit different than number 2 and number 3. So when I'm doing factoring and I have an a value, I have to do 6 times negative 11. So I need to think about two numbers that multiply to negative 66 but add to negative 5. So in this case, that would be negative 11 and 6. So what I'm going to do is I'm going to split my middle into a negative 11x plus a 6x. Now I'm going to bring down the last term and bring down the first term, and then I'm going to factor by grouping. So in my first pair, my GCF is an x, and I'll be left with 6x minus 11. My second pair, the GCF would be 1, and I'll be left with 6x minus 11. So my final factored form will be 6x minus 11 and x plus 1. Now I would set each of those equal to 0 and solve. So one of my solutions will be 11/6, and my other solution will be -11/6.